In this video we are going to find some missing sides of right triangles. And so to do this we're going to use the Pythagorean Theorem and use it in kind of a variety of ways. We'll have to use it twice in each of these problems. So let's take a look at this first problem here where we have a triangle with sides 11.31 and 11.31, and then we have another one with side 6x and then kind of an unknown that we'll find. So what we need to do first is look at this big triangle here. It is a right triangle, and so we need to find the hypotenuse, because remember the hypotenuse is the one that's always opposite our right angle. So to do that we use the Pythagorean Theorem of a squared plus b squared equals c squared. So we take 11.31 squared plus 11.31 squared equals c squared. When we take 11 and 31/100 squared, we get 127. We'll just call it 92 plus 127.92 equals c squared. Then let's add those two together and you get 255 and 84/100 equals c squared. And then to get rid of the squared we take the square root of both sides, which comes out to be 15.994, which is about 16. So we now know that this hypotenuse, this length all the way along here, is 16. And these tick marks here mean that it's basically cut in half. So this part right here is 8, and this part right here is 8. So then we can go into our second triangle here, and we have side 6, side 8, and then an unknown side of x. And we see that x is our hypotenuse. So we're going to again use a squared plus b squared equals c squared. So we say 6 squared plus 8 squared equals c squared. 6 squared is 36, 8 squared is 64 equals c squared. When we add those together we get 100. And so we get 100 equals c squared. Take the square root of both sides. And 10 is c. So x, our unknown, is 10. Alright, in this next example we see that we have this big triangle, and then we have this one that looks like it's a little triangle, but the Pythagorean theorem only applies with right triangles. So what we're going to do is we're going to find the missing side lengths of the big triangle, which here would be the side. We'll call that b. So we're going to solve for b, and then we'll know y, and then we'll be able to solve for x. So let's go ahead and get started. So here we have a leg of 4, so we're going to use Pythagorean theorem. And then we have the leg of b, and that equals the hypotenuse of c. So 4 squared is 16 plus b squared equals 5 squared, which we could say 16 plus b squared equals 25. Subtract 16 from both sides. B squared equals 9. Take the square root of both sides. B equals 3. So we know that this whole thing equals 3. When we take 1 away, 3 minus 1, we know that y equals 2. So this whole thing here is just 2. Now what I'm going to do is I'm going to redraw this triangle, this smaller triangle, so we can see it. Still has a side length of 4 here, and has a side length of 2 here. So now we can use, so then x is here. We can use the Pythagorean theorem again and say 4 squared plus 2 squared equals x squared. 4 squared is 16, 2 squared is 4 equals x squared. 16 plus 4 is 20, which equals x squared. And then we take the square root of both sides. And the square root of 20 is about 4 and 47/100. So there are 2 examples where we have to use the Pythagorean theorem twice. Make sure you like my video